Now I am going to show you how to write procedure for the detected 2 acid radical. First part of the analysis is preliminary test. Physical state of our salt is solid. Appearance, whether you write this or not, you must write the second one. First and second one put together, we can consider it as one. Appearance, our salt mixture is crystalline. So I am removing this amorphous. Color, second one is color. Our salt is white color. You can write white as colorless or colorless as white. Both are same. I just remove colorless, white in color. Okay, we have detected the solubility. The given salt is soluble in water. So just we have to write only water. Now I am removing dilute hydrochloric acid, dilute nitric acid. Okay, the second part of analysis is detection of acid radical. First we have carried out the test which is for carbonate or first group acid radical. Okay, we have taken little salt mixture, to that we have added dilute hydrochloric acid and no brisk effervescence. So we can say that first group acid radical is absent. Then what we did, we have taken little salt mixture in a dry test tube, and to that we have added 2 or 3 drops of concentrated sulfuric acid. Vigorous reaction in cold. Then what we did, we have observed that is a colorless fuming gas. So we should write second group acid radical is present and the colorless gas liberated is hydrogen chloride. It is due to the presence of chloride. So we can write here maybe chloride acid radical. Further, to say that it is a chloride acid radical, we did this test. We have taken a glass rod, we dipped into ammonium hydroxide, then we have exposed to the outcoming gas. On exposing a glass rod dipped in ammonium hydroxide, we have observed dense white fumes. Therefore, now we can say that chloride is present. Further, we confirmed the chloride acid radical by carrying out chromyl chloride test. This is the confirmatory test for chloride acid radical. For that, we have taken little salt mixture in a dry test tube. We have added equal amount of solid potassium dichromate, and to that we have added 3 drops of concentrated sulfuric acid, and to get more vapors we have heated and we passed the vapors into another test tube containing water, and on mixing the water with the vapors we have got yellow color solution, that is due to the formation of chromic acid. Then we have added 3 drops of ammonium hydroxide to neutralize excess of chromyl chloride. Then we have added 3 drops of acetic acid to neutralize excess of ammonium hydroxide. Finally, we have added 3 drops of lead acetate, and on shaking we have got bright yellow precipitate that confirms chloride acid radical. Then we have proceeded to third group acid radical, and they are called independent acid radical. We carried out a test first for borate acid radical. For that purpose, we have taken little salt mixture in a test tube. To that we have added 5 drops of ethyl alcohol, 2 drops of concentrated sulfuric acid. We have heated and we have ignited the vapors coming out, and we have got blue flame, not green flame, no green edged flame. Third group acid radical borate is absent. Then we have carried out a test for phosphate. For that we have taken little salt mixture, then we have added 5 drops of concentrated nitric acid, and we have heated to dissolve the salt, and we cooled, and then we have added ammonium molybdate, and adding ammonium molybdate no bright yellow precipitate. So we should write third group acid radical phosphate is absent. So finally, now we have to detect the presence of sulfate acid radical. For that purpose, we have taken little salt mixture, to that we have added water, and we got the solution called solution of the salt. To that we have added 2 drops of dilute hydrochloric acid. Then we have added barium chloride solution. We got white precipitate. That is the observation we made. And to that white precipitate we have added excess of dilute hydrochloric acid. On adding excess of dilute hydrochloric acid, the white precipitate remains as insoluble. Therefore, now we can say that third group acid radical is present and essentially it is sulfate. Sulfate is present and it is confirmed. So, with this detection of 2 acid radical is completed. Now, we shall proceed to the detection of basic radical. I am going to demonstrate the detection of basic radical. Along the demonstration, I am going to explain the detection of basic radical. I am going to demonstrate basic radicals. Basic radicals are classified into 6 groups. They are detected by taking original solution. Original solution is a solution in which the salt is soluble in a suitable solvent. The solvents are selected in the order first with water, next with dilute hydrochloric acid, finally with dilute nitric acid. Excepting ammonium basic radical, NH4 plus, rest of the basic radicals are essentially metal ions. We are going to detect the basic radical ammonium ion in the beginning, since it is the only basic radical which is not a metal ion, and the presence or absence of ammonium basic radical can be reported either in the beginning or at the end after magnesium in the 6th group. Only for ammonium basic radical we take the salt mixture, and we carry out the detection of ammonium basic radical in the beginning, since it is easy to identify and ammonium basic radical does not interfere with any other radicals. Therefore, we carry out ammonium basic radical in the beginning only to make the analysis of basic radical easy. So, first I am going to demonstrate the identification, analysis of basic radical, then I am going to show you how to write procedure for the detected basic radical in order to make the analysis easy. Now, first I am going to carry out test for ammonium basic radical. For the question, what is a basic radical? Answer is, basic radical is a positively charged ion. They are also called cation. And all the basic radicals are metal ions excepting ammonium ion. Basic radicals can also be defined as part of the base present in the salt carrying positive charge. Basic radicals are classified into 6 groups depending on their reactivity, depending on their solubility. Now, I am going to demonstrate the detection of ammonium basic radical. Only for this, we take salt mixture. Now, I am taking small quantity of salt mixture in a semi-micro test tube. To this, I am going to add sodium hydroxide. One of the characteristic property of the ammonium salts is, on heating ammonium salts with sodium hydroxide, they decomposes, liberates pungent odor gas. That pungent odor gas is ammonia. If ammonium basic radical is present, we get pungent odor ammonia gas on heating with sodium hydroxide solution. To the salt mixture, now I am adding 2 to 3 drops of sodium hydroxide, maximum 5 drops. In all the tests, we need to add reagents dropwise only. So, now I am going to heat the salt mixture with sodium hydroxide at the tip of the flame. Just few seconds. Now you see the solution is boiling. Now I am going to inhale the outcoming vapors by waving the mouth of the test tube. We are not supposed to inhale directly since we may intake lot of fumes. To avoid that, to inhale only small amount of fumes, we have to inhale gently by waving the mouth of the test tube. You see now, on inhaling, I have not got any pungent odor. Therefore, I can say ammonium basic radical is absent. So, this we can report in the beginning or at the end in the sixth group after magnesium. Both are allowed. Okay. Now, I am going to proceed to the first group basic radical analysis. Remember, first group and second group basic radicals are excluded from the syllabus, both from the practice as well as from the practical exam syllabus. However, for the students, we are going to demonstrate in the class the absence of first group and second group basic radical. To save some time, I just skip the analysis of first group and second group basic radical since it will not be given. To the first group basic radical and to the second group basic radical, we are not carrying out the test since they are excluded from the practical exam syllabus. Therefore, I am going to carry out directly the third group basic radical analysis. For that, I take small quantity of the salt and I dissolve in the solvent in which it is soluble to get original solution, which can also be called as stock solution. As I have already told, original solution is a solution in which the salt is soluble in a suitable solvent. So, I am going to prepare stock solution or original solution by taking small quantity of the salt in a small beaker. It's a 25 ml beaker. I am going to transfer just one spatula or maximum 2 spatula of the salt into the beaker. And we know the solvent in which it is soluble. We have already carried out the solubility test. This salt is soluble in water. So, I am going to dissolve the I am going to dissolve the salt in water. I am dissolving the salt in minimum volume of water, that is the solvent, and I am going to stir. If the salt is completely not soluble, if any salt left over in the beaker, now to dissolve, I am adding some more water. We are supposed to dissolve the salt with minimum amount or volume of solvent to get concentrated solution, so that proper precipitation takes place in the analysis of basic radical or detection of basic radical. If the solution is diluted, then sufficient number of cations, basic radicals may not be available, and there will be no proper precipitation, and our observation may not be proper. You see, I have added to check whether the solution is concentrated or completely saturated, concentrated. I am adding some more quantity salt and I am stirring in a glass rod. See, the salt is still dissolving. This indicates that the solution is not concentrated or saturated. So, to get concentrated solution, I am going to add some more quantity. You see now, some amount of salt is remaining in the beaker. So, I can say that the solution is saturated or concentrated. This is called original solution. Just you prepare stock solution, original solution, so that you need not to prepare again and again the original solution required for the analysis of basic radical. You can stock this, you can keep this aside, and whenever you wanted to carry out any group, you just take 5 drops from this stock solution. Okay. Now I am going to carry out the analysis of third group basic radical or detection of third group basic radical. As I have already told, I am not demonstrate first group and second group, since those two groups are not in the exam syllabus. Now I am demonstrating the third group analysis or detection of third group basic radical. For that, I have taken about 1 ml of OS, original solution or stock solution. To this, I am going to add group reagent. Third group basic radical group reagents are solid ammonium chloride and ammonium hydroxide. We have to add about half a spatula of ammonium chloride to this much volume of original solution. After adding half a spatula of ammonium chloride, solid ammonium chloride, dissolve by shaking. Only after dissolving ammonium chloride in the original solution, you need to add ammonium hydroxide. Now I am going to add ammonium hydroxide dropwise in excess. Excess means how much? First, we need to add 2-3 drops of ammonium hydroxide. After adding 2-3 drops of ammonium hydroxide, mix it well and wave the mouth of the test tube and inhale. If you get pungent odor, ammonia, it is excess. If the ammonium hydroxide added is not excess, you won't get pungent odor. So, we cannot explain how the pungent odor will be. You have to experience the pungent odor. For that purpose, you just take ammonium hydroxide bottle and just inhale the odor of ammonia. So, whatever the odor you get, that is the pungent odor. You see now? To the original solution, I have added ammonium hydroxide solid, I dissolved it, then I have added ammonium hydroxide dropwise in excess. I can say that it is excess because I am getting pungent odor gas. Now you can see a white gelatinous precipitate. That white gelatinous precipitate formed is aluminum hydroxide. So now I can say that third group basic radical is present and aluminum is present. Now I have to confirm the presence of aluminum basic radical. For that purpose, we have to centrifuge this. In order to get more amount of white gelatinous precipitate, I am going to add some more ammonium hydroxide to complete the precipitation of all the aluminum ions to get aluminum hydroxide white gelatinous precipitate. Okay. So, to get more amount of white gelatinous precipitate, to this I am going to add some more original solution and some more ammonium chloride and few more drops of ammonium hydroxide. Then I centrifuge this. We carry out centrifuge process in a centrifuge tube. It is a special tube having a cone shape. To this centrifuge tube, I am going to transfer the precipitate formed. And I am going to keep this white gelatinous precipitate taken in the centrifuge tube into a centrifuge machine. In the centrifuge machine, to balance the centrifugal force, I am going to take almost equal volume of water in another centrifuge tube, and we have to keep this centrifuge tube in the opposite direction to prevent the spilling out of solution or precipitate from the centrifuge tube. We have to keep another centrifuge tube containing equal volume of water. Okay. ಅಲ್ಲಿ ಸ್ವಿಚ್ಚು ರೆಡಿ ಇದೆಯಾ ಗಣೇಶ್? ಇರು ನಿಮಿಷ, ಇಡು. Now our laboratory assistant Mr. Ganesh is keeping the centrifuge tube into the centrifuge machine. So one test tube containing precipitate in one direction, another test tube, centrifuge tube containing water in the opposite direction. Now he is closing the centrifuge machine tap and is starting the centrifuge. So now the centrifuge machine is working. We have to centrifuge for about 10 to 20 seconds, maximum 30 seconds. Within the time, the precipitate will settle at the bottom, that is called residue, and the clear solution will settle at the top, that is called centrifugate. That centrifugate contain another basic radical in the form of ions. The residue is aluminum hydroxide, which is formed from aluminum ion basic radical. The centrifuge machine rotating motion stops. Now Mr. Ganesh Reddy is taking out the centrifuge tube from the centrifuge machine. Now you see centrifugation is got over. The residue is settled, white gelatinous precipitate, and that is called residue, which is aluminum hydroxide. The centrifugate, I am going to decant this to another test tube, and we need this to carry out the detection of another basic radical. So now I am decanting the centrifugate to another centrifuge tube, empty centrifuge tube. Okay. This residue now I have to confirm whether it is aluminum hydroxide formed from aluminum or not. For that purpose, I am going to add sodium hydroxide. If this white gelatinous precipitate is aluminum hydroxide, on adding 2-3 maximum 5 drops of sodium hydroxide and on shaking, it should dissolve. You see, it is dissolving. The precipitate is dissolved and a clear solution is formed. So this clear solution is sodium aluminate. To this clear solution, I am going to add ammonium chloride solid to confirm. The conformity test for aluminum basic radical is to this clear solution. On adding ammonium chloride solid and on shaking, it should dissolve and white gelatinous precipitate should reappear. If it doesn't reappear, just we have to warm and cool. On heating and cooling, white gelatinous precipitate should reappear. Now you see, just on adding small amount of ammonium chloride solid and on shaking, it has dissolved and reacted with sodium aluminate to give back aluminum hydroxide precipitate. So with this, we can confirm that aluminum basic radical. Okay, for the basic radical